Hi, it's me Nigab Khatiora from Avila University. Today I'm going to present the presentation of my final project on my course Foundation of Business Analytics. So with the flow of my presentation, first begin with the overview of the presentation. I mentioned the some few points and they are selection of data and its processing, cleaning, explanation and representation in charts, statistical calculation, setting a primary research question, analysis of data, result interpretation and conclusion. So after the overview, I have selected the data from the kaggle.com investment survey dataset was selected. Dataset have 9 variables and 100 observation. So looking over the data, there was no any missing files, so it was clear. And I have attached to this slide. The dataset includes a combination of categorical and numerical variables. So now forwarding towards the variables and its types. At first there is a gender, which is categorical. Second is age, which is numerical. Third, working professional, which is a categorical. Fourth is the annual income, that is numerical. Fifth, mode of investment, which is categorical. Sixth, investment per month, which is numerical. Seventh, resource use, which is categorical. Eight, goal for investment, which is categorical. And duration to save, which is the last one, which is the numerical. And after that, I represent the graph like a histogram and scatter plot. Looking over the graph in scatter plot, I've used two variables, so which is age and annual income. Uh, from the data we have present the graph of scatter plot. This plot shows a cluster distribution of points, indicating that most data points fall within a specific age and income range. Age seems to mostly range from 20 to 40 years, and annual income is primarily between 1 lakh and 4 lakh, with a few outliers. Similarly, there is a histogram where I have taken only one variables, annual income. From there, we calculated the bins and frequency. From the bins and frequency, there is a graph of histogram. So in histogram is a like a in histogram, the majority of individuals have annual income in the lower range between 0 and 3 lakh. As income increases, the number of individuals decreases significantly, with very few people earning above 4 lakh. So after this, we move towards the descriptive statistics. Descriptive statistics like mean, median, mode, and standard deviation are calculated from given data. I've calculated from two variables, investment per month and annual income. There is the calculation of mean, standard error, median, mode, and others. Like in investment per month, we can see that the mean is 2863, standard deviation is 4052. Likewise, in annual income, we can see mean is 166,440.8, standard deviation 161,676.8824. So these are the value of the descriptive statistics. After this, we have to set a primary research question. So I have set one question, that is there significant linear relationship between the annual income and the investment per month? So for it, we have to first set the hypothesis. In the null hypothesis, which states that no significant relationship exists between the independent variable and the dependent variable. Likewise, in alternative hypothesis, which states that there is a significant relationship between the independent variable and the dependent variable. So after that, we have analysis the data, perform regression that involves ANOVA, which is also known as analysis of variance. We can see the regression statistics. Multiple R has the value 0.267. Likewise, R square has the value 0.071. Adjusted R square has the value 0.062, and the standard error has the value 3924. So that's the regression statistics. Below the it, there is the ANOVA, which shows the regression and residual, and also we have got the coefficient value of the intercept and the x variable one. So after this, go through the go after this it's time for the regression equation. The simple linear regression equation with intercept is y is equal to mx plus b, where y is the independent variable, m is the slope of the line, x is the independent variable, b is the y intercept. So after that the equation is y is equal to 0.00671 x plus 1746.97. So after the statistic calculation, it's time for the result interpretation. So since the p value 0.071 is less than the significant level, we reject the null hypothesis. So likewise, from the regression equation, it indicates that for each 1 unit increase in x variable 1, y is expected to increase by approximately 0.00671 units. And we have also the value of r square, which is 0.0716. This indicates that 7.16% of the variability in y can be explained by x variable. Likewise, adjusted r square 0.0621. The adjusted r2 square take into account the number of predicted in the model and provides a more accurate measure of the model's explanatory power. So these were the result interpretation, and after this there is the summary of the statistical calculation with the heading conclusion. So the analysis here does determine that there is a significant statistical relationship between x variable and y, but what the r square values learned suggests is one that also need to consider more variables and perhaps more advanced modeling techniques to better explain what contributes to y. So this was the conclusion of the statistic calculation, and overall data and the concept was taken from the kaggle.com and the open into statistic, which I have mentioned in the reference, which helped me to present my presentation. Hope you like it. Thank you.